Hang on, I think
Wait,
you
who's
might.
this? You say something.
Yeah, because it's
Okay.
Hello, everybody. Could one of you say if I'm audible or not?
We can hear you.
Thank you. Okay. I am Satish, readable? Yeah. And this is Syllabus 205A, section 1. So as it is clear, we are going to have this week, hopefully this week, only online, and hopefully we can get back to classrooms next week, but that depends on what the university administration decides. What I'm going to do today is go over the syllabus and primarily convey how you want to spend your time studying. Basically, the idea is that the exams are slightly, significantly harder to score relative to the homework. So you want to make sure that you get as many points as you can in the homework. So I want to stress on that. So I'll spend a little time on going over the logistics and then do a little bit of learning that will be useful for the first homework. So that's what we can go do today. So broadly speaking, what we have in this course is, again, as far as logistics goes, not the subject matter itself, there will be homework and exams. That's the two assessments we will have in this course. So homework will constitute 40% of your points, and exams will be 60 points. This again breaks into, there will be midterm exams. So there will be 3 midterm exams and 1 final exam. Is this readable? Like, I know there is a small glare on coming from the window, but I cannot do much there. Reasonable?
It's pretty clear except for midterms and finals, but everything else is pretty eligible.
Okay, so avoid that side to a certain extent, right? Okay, so let me, what can I do? Let's see. So let me try to write on this side. So the exams break into midterms, and there is a final exam. Midterms, there will be 3 midterms, each one they will be equally distributed. And homework, I call it homework. There are 2 components to that. One is the homework itself, and the second is what I will call quizzes. And this will be 30, that will be 10. But what we want to, for this part, what I'm trying to stress is that there is a 40 and a 60 distribution. But the important piece is this is easy to score, right? What I mean by easy and hard is actually dependent on the context. It's not easy in conceptually. Conceptually, actually, these two are probably exactly the same question. I might ask a question from homework in the exam, and suddenly it gets harder to score because in the exam, you don't have any help. During homework, you have the textbook, you have the lecture notes, you have the internet as a whole, and you can also take help from anyone you want. And I will go over that more carefully. Since you have so much help or resources available, this becomes very easy to score. On the other hand, this is you're on your own. You're taking the exam in a classroom. The same question, even with a very small minor change, becomes a little harder for students to do on their own. And in that sense, this is harder to score. It's the same question, but it's harder to score. This is easy. So the point is, you want to take as much as possible of the homework. You don't want to miss that. So how does this boil down? Again, the important point I'm trying to convey is that since this is easy to score statistically, based on statistics of whatever the few number of times that I've taught these courses, most of the students manage to get 100%, or many of the students manage to get 100% in the homework, plus if you manage to get about, let's say 82% approx that in exams, that leads to about 90 approximately. So if you want to get an A in the class, you don't have to get an A in the exam. You can manage to get lower in the exam, but get almost everything in the homework. So that's what I'm trying to point out. If you do not get 100%, then you need to get a lot more in the exam. So that's the point. If you're in, so this will be an A. If you want a B, this could be 95. Again, it is relatively easy to do this, plus 70% in exams. And that could be an 80, and you can keep going. So this could be 90% in homework plus 60%. So that's what you want to keep in mind. Again, I know there might be situations where you really want to do homework on your own completely, but do take help in the sense not from others. It could be the textbook itself, textbook, me, lecture notes, all those are considered resources. Often these things are repeated from the lectures itself, and in that sense, you have resources available to score high. So that's what you want to take home. Now let me go through the syllabus itself. I will point out where exactly the syllabus is. So let me tell a few links. There are 2 web pages we will use. So this will be called the course web page. And the second will be the D2L. This is often called my courses. The course web page is maintained by me. It is not the university web page. So this is SPHYS. That is built from, that word is built from a mathematical function .com. So SPIX, and then /TC, so that's teaching courses, and then again a slash, you continuously write this, and the course number, that's 2022-01 stands for January, SIU, and then there's physics P205A. Since this is an online class, you should be able to type this right now on your browser, and this should take you to a page which will have a lot of resources meant for this course. In fact, you should be able to get a syllabus. You should be able to access the syllabus right away in the first paragraph or in the first few lines. There is also the link to this page is available on D2L. If you have your D2L open, you should be able to click on a link there, and that should take you there. In the very top part of this page, you should be able to access the syllabus. It's a 2-page document that tries to tell you what. That's. There is a chat I'm seeing. It is not PC, it is TC. T as in Tanko. Right? T as in Tom, T as in Tanko. That's correct. You should be able to access that. Okay. This course, what is it going to be about? Very simplistically speaking, we will, or very Yeah, let's just simplistically, if I were to drop this chalk, it falls down, and we would like to know exactly what determines its motion. If I were to throw a stone, where will it fall? And it is pretty significant what we are talking about there, because we are pretty much predicting. If I can throw a stone, and before throwing it, I can tell you that if I throw it at a certain angle with a certain velocity, it is going to, hold on, before I continue. The camera is so blurry, I cannot see it that well. Is it really bad? Oh, maybe I can tell you. Is it very blurry for everyone?
It cuts in and out.
Okay.
I can email you a picture of it.
Oh no, I trust you that. It's not about that. Okay. The point is, will we be able to manage with this?
I mean, I'll probably just ask what it says. I think it's fine.
Yeah.
Here is one thing I can suggest, because I don't have much option. It's not that I can improve this too much. So this is a I will have a recording of this, and that will be made available on the same course webpage, if that is at all. Yeah, it is manageable. I can read most of it. Yeah, if it is manageable, can we proceed?
Yeah, I think it's good.
Yeah, so yeah, this is not really nice. If many of you are not able to read. Okay, yeah, for now, let me proceed. And next time I'll try to do something different. That's one thing I can try. I am using Ethernet, so I expected the connection to be good, and I've used this in the past, so I expected it should be going fine. But what I can do is that I will record this, and hopefully those who do not have a very good internet, the recording should do the job. And we are mostly going over the syllabus today, so hopefully it doesn't hurt much. Okay, so if you guys allow me, I'll proceed through the rest of going over the syllabus. Okay. Yeah, it's not the best thing. Okay, so I was saying that yeah, I was talking about the course. We are going to be talking about how we can understand where a stone falls when we throw it at a certain angle with a certain velocity. And it is remarkable in the sense that we are actually predicting. Remember, it is very hard to predict what happens in our life. We cannot say whether we are going to live or not live a few days down the line, but we can predict certain things, like, for example, if we throw a stone significantly faster, for example, a space shuttle, we are practically throwing it, and we can predict that 6 months down the line, it is going to fall on Mars, right? So that's prediction. And that's really prediction in the sense that we are able to predict the path of an object, not the life of something, but a small prediction in the sense that we throw something and reach there. So that's what we are going to talk about. And remarkably, it's the same equations that govern what happens to a stone when you drop it in the presence of gravity or on the surface of Earth. There is a significant a generality in those equations that you can start from here and then extend it out there. Of course, with a lot of details to be added. So that's broadly what we will talk about, how you predict where a stone will fall, in a sense, again, in a simplistic manner. What about the textbook? The textbook will be that of Survey and Jewett. It says Physics for Scientists and Engineers. We will use the 9th edition. I am aware that later editions are available, but we will be fine with the 9th edition. For that matter, you can use whichever edition you want. Most of the content remains the same. I will not be referring to any specific problem in the textbook. Whenever I do refer to a problem, I will actually typeset the whole problem. So it doesn't matter from which edition it is coming from. Most of the content remains the same. So you should be okay which one, which edition you're using. But as far as the textbook goes, for official matters, we are using the 9th edition. And if you want to buy a textbook, that's the best one to buy. Web pages, we will have this as one of the web page. That will be the course web page. And then there is D2L, where we will mostly use that for submissions. For example, when you do a homework, you will have to submit it. So you will scan your homework. If there are multiple pages, you will make a single PDF file out of it and you will upload it on D2L. The same thing happens with quizzes. Again, I'll try to go over it in more detail soon. Lectures, hopefully lectures will be in the actual classroom, auditorium, Neckers 440. It can sit about 100 students, so we will be less than that, so that should be sufficient room. But the first week of classes, that is the first 3 lectures, we will have it in this format, hopefully in a better form. Since you guys say it is not very nicely readable, I'll try to move the location so that it is better. Okay, evaluation. I said that earlier, that there is 40% of homework like stuff, basically homework and quiz, and 60% will be midterm exams and final exam. Coming to the homework, once I have a lecture almost every week, there will be homeworks given to you. The first homework is already available on the course webpage. If you go there, if you go down a little bit, you should be able to see homework number 1. And if you click on that, you should be able to see that there are about 4 or 5 problems that you have to address to. Once you have the homework, if you attend the lectures, what I suggest is that either you go and read the textbook or the lecture notes from the classroom and immediately start on the homework. And it's a cyclic process in the sense you look into the homework. If you're not able to, and you're not understanding how to begin the homework, you come back to the textbook or the lecture examples and go back. So it's a, try to do the homework, come back and try to understand the lectures, go back and try to do the homework and so on. So that is a cyclic process there. You're allowed to take help. You can take help from the textbook, internet, even solutions. The homework that I give is pretty much the same as what I gave in the last year, spring semester, exactly same questions. And I have made solutions at the time. I recorded the solutions. So I explained the problems in those videos, and those videos are available in public. So in principle, the solutions for the homework are already out there. My solutions are already out there. But that's where the responsibility comes in. When you start the homework, I will discourage you guys to directly go into the solutions. Try to attempt it on your own. Use the textbook, use lecture notes, and then the solutions. If you have to depend on completely the solutions, that means you're not completely understanding the concept. If you have used the solutions, that means you have to go and work on extra problems from the textbook. So that's your responsibility to realize that more resources you're using, including the textbook, including the internet and the solutions, that means that you have to spend extra time, more time on it. If you're able to do the homework, there is a good chance that you understood the subject matter reasonably. So if you're able to do the homework that on your own, that means you will be able to do the exam problems also on your own. If you are depending on the solutions, that means you might struggle in the exams, because in the exams, you won't have help and other resources. So that's something, some responsibility you have to take on yourself. About the exams will be held once in a month. That means 3 weeks. We do homeworks every 4th week. We will have an exam. So that means in 4 months, which is about a semester, we will have 3 midterm exams, and the 4th one will be the final exam. The final exam will be cumulative. Even the midterm exams in principle are cumulative. But what happens is that we'll be learning so many new things. We will spend most of the exams on what we have learned since the earlier midterm, but concepts build on each other. So it is not really correct that you can ignore whatever we did before. So in principle, it is cumulative. But having said that, I will usually spend more time on topics that we studied at the end. That's about the exams. That is also what I call quizzes. So this is quizzes. Now, quizzes are slightly different from the homework in the sense this could be open-ended questions. So the questions could be open-ended. That means to say that not all the problems need to have a right or a wrong answer. It is more for you to ponder about certain concepts and just think about it rather than actually try to find a right exact numerical answer. Most often it might be just a qualitative answer will be more than sufficient. Having said that, it becomes difficult to grade these problems, and due to that reason, I grade them just for participation. So if you have submitted an answer to a quiz problem, that should most probably give you full points. If you have addressed the question very broadly, that should be sufficient, and you should be good enough with that. That also means to say that since it's open-ended, do not spend more than 10 minutes on this. If you want to, you can, if you find certain concepts very interesting and you try to ponder on it a lot, that's perfectly fine. But what I suggest is that as far as grading purposes go, for grading or for getting the points, do not spend more than 5 to 10 minutes. Often students finish it very quickly, just something related to the question you answer, and that should be good enough. But I try to make the questions nice enough so that people do get interested, and sometimes you tend to spend some time on it. In that sense, quizzes seems very trivial, but this there is a quiz after every lecture, including today's lecture. After the lecture, before the next lecture, there will be the quiz for today you have to submit. And that sort of brings in a discipline that you have to submit something after every lecture. And that I use as a way of participation. So let us say you get in quizzes, you get about 8.0 out of 10 points, right? So it's a total of 10 points, and you get, so let me write 10 in case that 0 is not visible. So you get 8 out of 10. That again, that's unlikely based on what I have seen. Most of the students get 10 out of 10 because it is based on participation. Most of the students do participate completely and you get 4 points. Many students do that. But suppose you get 8 points. It not only helps you with scoring points in the quizzes, it helps you also with what I call a curve. So let's say, let's take an example. That after at the end of the semester, you have about 60 points out of 100. So you have a total of 60 out of 100, but I at that point decide that I want to give some points in a fair manner to everyone. So what I do is I take the 60, that's how much you have scored, and I try to return back some of what you have lost. So for example, how much you have lost is 100 minus 60, so that's 40 points you have lost. And I try to return back a little bit of that. So let's say I decide to give 20% of what you have lost. So that's 0.2. So that's 20% of the 40 points that you have lost. So that I decide to return back. But having said that, you will be able to get those points only if you have full points in the quizzes. For example, if you have got only 8 points out of 10, then you get only 0.8. So you get only 80% of what I did. So that's a way of curving. My point I want to stress is that quizzes, what you earn in quizzes, not only helps you with the quizzes, it also decides how much points I return back to you. So that's a easy participation points that decides your curve also. That's reasonably written in the syllabus. If you do not understand this, we will get to that whenever we finish the first midterm. I'll talk about that in more detail. So that's about the grading, and there is a syllabus attachment which pretty much has a lot of links concerning other points that happens in the university. It's a useful one place where you get all the links, which is pretty much collected by the university administration. So that's about the syllabus. I will teach a little bit. I'll go ahead and teach a little bit today, but before I do that, any questions on what we talked about here concerning syllabus, something that I completely missed? Any curiosity you have? Anything? No questions at all?
Just double checking. Is the homework coming from the book or are you assigning it?
Is the question, is the homework coming from the book or am I assigning it?
Yeah.
The homework is motivated from the book. I change it a little bit. So often I typeset the homework. Often it is the textbook problem itself, identical, but often I change it a little bit. And it helps, if it helps, this is the following comment. What I do is that I give a homework problem, and in exam, what you can expect is that I will change that problem very tiny bit. For example, velocity is distance over time. In the homework, I will give you the distance and time and ask you to calculate velocity. But in the exam, I'll give you velocity and distance and ask you to calculate time. Something very simple. The whole context remains the same, but a small twist, very minor twist, and I ask you to redo the problem. So that's what I try to do. Does that help?
Perfect. Thank you.
Is there any way I could increase my volume? I'm having trouble hearing you. That would probably be on your side. I don't think on mic. Let's see. Maybe can I increase my Audio settings. Let's see. Nope. Not really. And whenever I'm speaking, it is going all the way to the high. So try it on your end. That's the best I can say. Yeah, so others say that the volume is fine for them. Yeah, try it on your side. Yeah. Again, when it is recorded, so probably the recording will help you guys. Yeah. Yeah, bad that there should be so many technological problems. Yeah. Any other questions concerning the syllabus? We'll get a lot of chance to go over this again. I'll try to repeat whatever is there as the semester, as we go through the lectures. So let me do a little bit of what could be useful for your homework. So we will be talking about motion, as I said, but before that, we need to talk about measurements, right? So, or even before that, I should say some deadlines, right? Let's see. So what are the things you need to take care of? That is a quiz that is due. So this is the month, that's the date, January 01, 10th day. So that's 01. So that's today's quiz, right? That's due on Wednesday at right before the class. So that's 12 p.m. and it is due on D2L. So you take, you write up whatever you have. You can typeset it if you want to, but usually it is harder to typeset equations, so it is often easier to just scan and send it either way. Send it, submit it on D2L. You need to have a PDF file for that. So as a quiz that is due on Wednesday, as a homework that is due on Friday. Again, right before the lecture, and it is due on D2. There is a midterm 1. It is relatively far, February 7. It is a Monday, and it is in class. Hopefully, we won't have any online issues this semester. If it is, then we'll think about it. But for now, it'll be held in class in NECUS 440. So those are the 3 things you want to take care of. Those are the due dates if you want. Since this is the first week, there is an online feature to this. I will be a little flexible if you have any challenges with the internet or anything. I will be flexible with the homework 1 and quiz. But in general, I am a little strict about the deadlines. Again, it is primarily about fairness. If most of the students are submitting it on time, I cannot allow someone else who is not submitted on time to, I cannot excuse that. But in the first week, because we are having this online scheme and that could be internet problems. Many of the students might not have proper internet, so I'll be flexible about that. Okay, so what are we doing in this course? As I said, we will talk about, we want to introduce ideas that can be used to describe motion. But before that, we need to make measurements, right? We want to talk about how far something goes, how much time does it take to go there, and what if you're heavy, like, so those are the three quantities we will talk about. So in general, we talk about numbers, right? So when we have numbers, we know how to add, right? So we know that, let's say, 3 plus 2. This 3 plus 2 is 5, right? That's trivial. All of us know this. But those are numbers. But now we want to associate units for this. So whenever we are doing measurements, we want to talk about adding masses to masses. So for example, what we will do here is, instead of doing 3 plus 2 is 5, I'll talk about 3 meters plus 2 meters is equal to 5 meters. Here M is a meter. So we are talking length. So if there is a rod that is 3 meters long, there is another rod that is 2 meters long. If I keep it one end of the rod in a straight line with respect to the other, the total length is 5 meters. So that's something you can talk about. If you have weights, I can have 3 kg plus 2 kg is equal to 5 kg. And I could have time, right? So there could be 3 seconds. So S here stands for seconds. 2 seconds is equal to 5 seconds. That's all straightforward again. It's a second. Very simple. What we do not do is we never say 3 kg plus 3 meters. Sorry, 2 meters, let's say, right? 3 kg plus, to just to be consistent, at 2 meters. If I were to ask you what is 3 kg plus 2 meters, that's not a reasonable thing to ask. You don't even ask. That's a wrong question. No, right? You do not ask that question, right? So that's what we want to point out. So so how do we capture the essence here, that I'm not allowed to do this? I always add the same quantities. So we want to associate a meaning to this, these statements, and that's where we will bring in the idea of dimensions. So what is the idea of a dimension? So if I have 3 kg, so notice here 3 plus 2, right? A number is, we are very good with working with numbers, but now we have this idea that we have to be adding only like things. By like, I mean, if I have a kg, I have to be adding kg to it. I cannot add kg and meters. So I will have a notation here that 3 kg, when I say, I would like to know what is the dimension of 3 kg. So the language is, what is the dimension of 3 kg? So I put a square bracket around this 3 kg. That means the dimension of 3 kg is, I don't care about the 3, get rid of the number 3. It is a kg that comes in, but kg is a mass, right? So this is associated with something that we call mass. So this will be said to be m. So what is the dimension of 3 kg? That's a mass, right? 3 kg is a mass. So that's what we mean by dimensions. And we are working with numbers here very quickly. In the next step, I'm going to upgrade this into a variable, and it will become a more powerful statement. Same thing do here. What's the dimension of 3 meters? 3 meters, that's a length. And let's say 3 seconds is time. Notice I don't care for the number. just to clarify that it has 3 has nothing to do with it, let me say 5 right here. And let me say 29 here. Just to show that that's an arbitrary thing. It does, I just dropped the number completely. This is the dimension associated with it, or what kind of measurement are we doing? We are doing a measurement of on mass. This is a length, that's a time, right? That's what we mean by that. But that's a number we usually by this stage of our studies, we have realized that we have already dealt sufficiently with algebra, and we know that we don't have to be working with numbers. We can use variables to represent something. So often what we'll do is, instead of working with numbers, we will say the dimension of x. So now I do not have a number there, do not have a unit there, but x represents something. Like typically we say x is equal to 2. Sometimes we say x equal to 2 kg, right? If I say x is equal to 2 kg, that means it's a mass. So this could be, if I say this, so this means that dimension of x is mass. That means this behaves like a mass. Not everything has to be distinctly mass, length, and time. That could be a combination too. Same thing here. We could have, let's say, y. This could be length. I could also have z right here. This could have mass times length, and there could be a time in the denominator. That's a possibility. So this has a feature that is having mass and a length and a time to it. So this is entirely different from length. Length is entirely different from time. So once we have variables, we can associate a dimension to it. It means what are the units, what kind of quantity it is. Clearly, these three are distinct. X is not the same as y, and y is not the same as z. If I were to make measurements, this I have to do it in kgs, this I have to do it in meters, and this I have to do in kg, meter, over second. So different unit altogether. So those are different quantities. Now coming back to the earlier statement that 3 kg plus 2 kg is 5 kg. How do I capture that in an equation? So let's have a equation, let's say example. So you come across, you're reading a book, and instead of going through from first page to the 27th page, you directly jump into the 27th page, and due to that reason, you have no idea what the notations are. And you come across an equation in that book, which says E is equal to mc squared. Right? We won't come across this equation in this course, but let's say you come across this equation in a book, but you have no idea of what E is, what M is, and what C squared, what C is. And here we have squared that C. But what you can say is that because in an equation, only like things, by like I mean if one side is kg, the other side also has to be kg. What we can conclude immediately is that dimension of E, the dimension of E has to be the same as dimension of mc squared. That's a simple statement we can make. If one side is a length, the other side also has to be the length. If one side is kg, the other side also has to be a kg. That's nice. What if I change this equation now? So let's say this is E is equal to m squared, c squared, plus let me add something to that. So let's say this is P. right? P times C. Now there is a plus sign here. That's algebraically you would say that, oh, this plus this is equal to E, but using our dimensional analysis, we know that this has to be the same as this, and it has to be exactly the same as this. It doesn't have, I don't have to add. Notice I'm putting an equal sign here. When it comes to dimensions, this is the same as this, which is the same as this. So dimensionally speaking, these three quantities are the same. Whatever it is, it could be kgs. Right? If it was mass, then we are saying this is mass, that's mass, that's mass. That's all we are trying to say. And that statement has this feature that you can deduce one relation with respect to the other. So very quickly, let's do a simple example. Like in your homework, this is the kind of example you have. Let's say example again. If you have an equation, x is equal to Vt plus half a t squared. Again, this is an equation you will study in this semester, but at this point, since we have not studied this equation, we don't know what this represents. But suppose I tell you that x, the dimension of x is length, let's say. I give you that information. That means whatever x is, it measures distance. If I were to use a ruler and try to measure it, so that's what x would do. If you have to measure x, you need a ruler for that. Let's also say that t is time. That means if I have to measure t, I have to use a clock or a watch, and that's time. But with that information, even though I don't know much about what V and A is, what I can deduce is that, if that's the case, this is X. This also, this total must be X, correct? So I can say X has to be the same as Vt. It doesn't matter whether there is a half AT squared. If this is length, this has to be length. Since this is length, I know that this is L. Split this, quantities, when they are having products, they can be multiplied, and the dimension of T is T. So this implies, right? So I have made a deduction without actually knowing what these quantities are, that whatever V is some length over time. I don't know what exactly, but if I were to make a measurement, I will have to use a length in the numerator and a time in the denominator. Often we write this as L t raised to minus 1, L raised to 1, and t raised to minus 1. Right, so that's a deduction you can make. You can similarly make a deduction about A, right? Since this also has to be equal to that, we can make a deduction about A, and we'll come back and do such examples on Wednesday. And your homework constitutes of these kind of problems. I'll encourage you guys to look into that. Okay, thank you. And I'll see you guys on Wednesday with hopefully a better way to present this.
Thank you.
Thank you. See ya.
Bye.
Okay.
Have a good day.
Bye.
Is the homework on the web page?
Yes, that's correct.
All right, thank you.
Mhm.
Do we have to do anything for the lab period today or not today?
I did not manage the lab, so you will get a separate instructor taking care of the lab. So you will have
All
to
right.
contact them separately.
All right, thank you.
Mhm. Okay, let me end this meeting.